Hello students, this is Anjana from Computer Science Department. In this class we are going to discuss about MACs based on the block ciphers and authenticated encryption and RSA with the SHA and DSS. Okay, now let us see what are the MACs based upon the block ciphers. So now let us see about DA. DA means data authentication algorithm. The data authentication algorithm based upon the data encryption standard uh, has been one of the most widely used MACs for a number of years. So the algorithm is both FIPS publication and FIPS means the standard which has been used in the large number of universities there. So these algorithms can be defined using the cipher block chaining, which can be called as CBC, the mode of operation data encryption standard with an initialization vector of 0. So the data, suppose whatever the data is, message or record or file or program, whatever it is, whatever the data which you want to be authenticate or grouped into the contiguous 64-bit blocks, that is D1, D2, D3 and so on Dn. If necessary, the final block is paired onto the right with zeros to form the full 64-bit block. So each one is divided into the block. If necessary, the final, whatever the final block, that block is paired with the right, paired on the right with zeros to form the, if it is not a full-fledged, so it is filled with the zeros to form a 64-bit block. So by using the data encryption standard algorithm E and the secret key K, the data authentication code is calculated as data authentication code is calculated as follows. See, now let us see how a data authentication code is calculated. So this is the time, if first time this is time 2 and this is time n minus 1, this is time n. So this is the data block 1, this is data block 2, this up to blocks, up to the message is divided into the blocks. Here in the previous slide we have discussed that data may be a record or file or audio or video, whatever it is a data. Okay, so we have applied the data DES data encryption standard encryption for that up to 56 bits. Here for this you have to perform the XOR operation for the next bit. Understand, after performing the data encryption standard you will get one code. No, for that code you have to apply the XOR operation for the next DES encryption. Just like that you are going to perform the XOR operation up to time n for the data block n. Okay, so based upon the FIPS standards, this is how we are going to perform the data encryption standards for this data authentication algorithm. Okay, understand, this is a bit 1 block, this is D2, Dn minus 1, up to these blocks we have divided. For that we are going to apply the data encryption standard algorithm here. After applying the data encryption standard algorithm we will get some bits. For that bit, after getting that one, we are going to perform the XOR operation with the next one which is applied for the data encryption standard. Just like that up to the block n we are going to apply there. So here O1 is the, after applying data encryption standard, the message what we'll get is the O1. So O1, how we'll get O1? Applying the encryption between the, this is a key that we have generated while we are performing the encryption, and D is the message. And next, how we will get O2? This is a key, and O1 plus D2. Sorry, O1 XOR operation D2. Okay, understand? Then how we will get O3? How we will get O3? O3 is equal to encryption of K comma D3 XOR operation of O2. Just like that up to ON we will perform the operations like this. Okay, so if it is a cipher based message authentication code, so the message length is not an integer multiple of a block size. So if this is message 1, message 2, message 3, up to just like that, if it is a message of multiple blocks size, here also after performing encryption, whatever the message that we'll get, we are going to give that message and we are going to perform XOR operation with that next message block. And next, after performing the XOR operation, we will get another message. With that message, we are going to perform the XOR operation with that another message. Just like that, we are going to perform the encryption. So the message length is an integer number of multiple block size. So if message length is not an integer multiple of block size, then here just like that you are going to perform the encryption like this. Finally, it will be padded with all the elements are padded with 0 to form it a 64-bit block size. Okay. So in this cipher based message authentication code also, why you are give it is, see, for a user it is not that much easy task to perform. So even if it is a easy task, it is not it is very difficult to calculate that much bits. So we are simply we are dividing it into the blocks. After dividing it into the blocks, we are performing the encryption for that particular data. After performing the encryption to that particular data, we are transferring that data to the next message block. Then we are going to perform the XOR operation between the data which is encrypted in the previous block and the data in the present block. So that is XOR operation between these two blocks. Okay. This is the cipher based message authentication code. This is our first one is if message length is the integer multiple of the block size. This one is message length is not the integer multiple of block size. Okay. So if you observe like that, C1 is equal to encryption of M1. So K is the key that is generated at the time of encryption. C2 is equal to E of K comma M2 plus XOR operation of C1. That is the key. K is the key that is generated at the time of this encryption. C3 is equal to encryption that is performed for this M2 M3 plus M3 XOR operation C2. Here K is the key that is generated at the time of the encryption. So and so on. Cn is equal to E of K comma Mn XOR operation Cn minus 1 XOR operation K1. That is the key that is generated at the time of this encryption. So T is the last bit, that is MSB of Cn. So this is S leftmost bit, the string with the string X. So T is the message authentication code, also referred as a tag. In the previous class we have already discussed about the tag. T length is the bit length of the T. Okay. So then let us see what is authenticated encryption. Authenticated encryption or authenticated encryption with the associated data is a form of encryption uh, which simultaneously provides the confidentiality, integrity, authenticity, and assurances on the data. So, whenever confidentiality, CIA in the previous classes, in the starting classes itself, we discussed about the confidentiality, integrity, and authenticity. Why we have to provide this confidentiality, integrity, and authenticity is so if the data, whenever if you are going to provide confidentiality for your data, then it is very helpful for that particular user that no other third party person can't able to access that data. Then integrity means we are going to integrate that message such that we are providing tight security for that message. Next one is we are going to provide authentication for that, such that whenever a receiver is going to receive that message at that particular time, he can able to know that okay, this is our message, then you can definitely use this data just like that. So these are the assurances on the data. So if you have observed that one, authenticated encryption or authenticated encryption with the associated data is a form of encryption with which it also which simultaneously provides, just like this one itself, it always simultaneously provides confidentiality, integrity, and authenticity. Okay, now let us see about the encryption. So input, what is the input? Plain text or key, and optionally a header in a plain text that will not be encrypted, but will be covered by the authenticity protection. So then how we will get the output? The ciphertext and authentication. Here how we will get the output is by using the ciphertext and authentication tag. So what is the input here? We are going to give the plain text comma key and optionally header in a plain text that will not be encrypted but will be covered by the authenticity protection. So here the output we will get is ciphertext and the authentication tag. So then what is a decryption? At the time of decryption, the cipher key and the authentication tag, suppose if you want to add the header you can add, otherwise the header is an optional thing. So uh, the ciphertext key, authentication tag and header, these are the things that we are going to add here. Next one, at the output, the plain text or an error if the authentication tag does not match the supplied ciphertext or the header we are going to use there. Okay, this is how we are going to perform the authenticated integration. So authenticated encryption. So authenticated encryption or authenticated encryption with the associated data, it is a form of encryption which simultaneously provides confidentiality, integrity as well as authenticity and about the assurances of the data. So whenever you are going to provide the encryption, if you are going to give the input a plain text key and optionally a header in the plain text, that will not be encrypted but will be covered by the authenticity protection. So here the output is the ciphertext and the authentication tag. So whenever you are going to provide the decryption, the input is the cipher key authentication tag and optionally a header. So if a plain text or an error, if the authentication tag does not match the supplied ciphertext or the header, whenever the plain text or error, if the authentication tag does not match, it will be a supplied ciphertext or the header. So so now let us see what are the approaches for the authenticated encryption. These are the some of the approaches for the authenticated encryption. Uh, First encrypt, then MAC. We can call it as encrypt, then ETEM. First encryption and MAC as well as simultaneously performed, we can say as E and M. First MAC, then encryption, we can see as a MTE. These are the approaches that we are going to apply for the authenticated encryption. Okay. See, this is the plain text. For this plain text, what you are going to perform here? You are going to perform the encryption. That key is generated here by using the hash function. A key is generated. So after performing the encryption, the plain text is converted into the ciphertext. So first we are going to encrypt that data, then we are getting into the MAC. Okay, then the ciphertext is transferred into the MAC. Here, first what you are going to, first you are taking the plain text from the sender side, you are encrypting that data with some key generated by the hash function. So after performing the encryption, the plain text is converted into the ciphertext. So based upon that, we are going to provide the MAC. So in the next time, first of all, your encryption and as well as MAC simultaneously performed. See, first encryption as well as hash function, by using the hash function, the MAC is performed. So here simultaneously encryption and hash function for the MAC is performed here. Both encryption and MAC is performed simultaneously here. Next, first MAC, then encryption. See, first the plain text. This is a plain text. By using the hash function, a key is generated. So with this plain text, we are going to send this plain text to the hash function, and then with that hash function we are going to apply that MAC. So with this plain text, again this plain text is taken. For the plain text we are going to perform the encryption by using this key. So this plain text is converted into the ciphertext. Okay, so if you have observed this one, so if you have taken a note, so first of all encryption hash then encrypt. So how we are going to perform hashing then encryption? See, first compute the cryptographic hash function over m as h is equal to h of m. Then encrypt the message plus hash function is equal to encryption of m to the h. This is how we are going to perform the encryption. If it is hash then encryption, just like this we are going to perform the encryption. So now let us see how we are going to perform the digital signatures. Another important application which is similar to the message authentication application is the digital signature. So the operation of the digital signature is similar to the topic, just like that MAC. Whatever the operations in the MAC, simply those are the rules that we are going to follow in the digital signature also. So the digital signatures are used for providing the major security services. Actually the digital service signatures are mainly used in the security services for the documents on the network. So in general scenario, a manual documents identified by the signature of involved parties. And next one, when a transaction is placed through a network, there is need for this kind of identification, and that was provided by the digital signature. So before placing the message over the network, the sender first encrypts the message with his own private key, and that itself provides a digital signature to the document. At the receiver side, the receiver decrypts the incoming message by using the sender's public key. So whenever the sender wants to send the data with the digital signature itself, he is going to encrypt the data. After that encryption, he can without any hesitation he can send the data to the receiver, such that we can say that it is a secured data. Why? Because already the digital signature is applied on the uh, definitely already the digital signature is applied on the ciphertext, sorry, plain text, so such that in general scenario, all these manual documents are identified by the signature of the involved parties. When the transaction is placed through the network, when the transaction is placed through the network, there is a need for this kind of identification, and that was provided by the digital signature. So that before placing the message over the network, the sender first encrypts the message with his own private key. That itself provides a digital signature to the document. So at the receiving side, the receiver decrypts the incoming message by using the sender's public key. Okay. So if we are signing the whole document, it is a A's public key and this is a A's private key. Here this is the plain text. Here we are going to perform the encryption. After performing the encryption, the plain text is converted into the ciphertext. So, after that, this ciphertext has to be decrypted. Why? Because the receiver has to understand this language, no? So that a decryption, after performing the decryption, the ciphertext is converted to the plain text. From the A to B, from source to the destination, the data is reached, just like this with security. So we cannot provide these aspects of security using the secret key. Okay, without secret key we can't able to provide the security. So the method that provides the authentication, this method provides the authentication and non-repudiation. Okay. So if you have observed this one, this is the original message, that is plain text. Here we are creating the signature, that is we are providing some private key here. This is the digital signature creation. From that the original message is this original message is added with some digital signature. After that one, that original message along with digital signature is sent to the receiver. Before receiving it to the receiver, that signature is verified by the receiver. With this, if the signature is matched with the sender signature, then he will receive that message automatically. So this is another technique that how the message is sending from the sender to the receiver with this digital signature concept. Okay. Next one, if you have observed, these are the properties of the digital signature. It must verify the author and date and time of the signature. And next one is it must authenticate the contents of that contents at the time of the signature. And next one is it must verifiable by the third parties to resolve the disputes. And next one, the digital signature must be a bit pattern. So the digital signature is not a unique to a sender, must be relatively easy to produce and to recognize and to verify, and can be computationally infeasible to add the message to the existing digital signature. Can be computationally infeasible to add the fraudulent digital signature to the given message. So it must be practical to store a copy of digital signature in the storage area. So if we maintain the copy of digital signature in the storage area, then it will be very easy for us. If some data loss may happen, then that particular time that storage copy will be helpful for us. So these are the properties. It must verify the author, date and time of the signature. It must authenticate the contents from the time of the signature. It must be verifiable by the third parties to resolve the disputes. And these are the digital signature requirements. The digital signature must be a bit pattern, and digital signature is unique to a sender, must be relatively easy to produce and to recognize and to verify, can be computationally infeasible to add the new message to the existing digital signature, and computationally infeasible to the fraudulent digital signature to the given message. So must be practical to store a copy of digital signature into the storage area. So when it comes to digital signature standard, the National Institute of Standards and Technology has published the Federal Information Processing Standard, which is known as Digital Signature Standard. The Digital Signature Standard makes the use of the secure hash algorithm, which is going to present a new digital signature technique. We can say it as a digital signature algorithm. Okay. Now let us see what is the DSS approach. The DSS uses an algorithm that is designed which is designed to provide only the digital signature function. Unlike RSA, it cannot be used for the encryption or key exchange. Nevertheless, it is a public key technique. So the DSS approach also makes use of the hash function. The hash code is provided as an input to a signature function along with the random number generated for this particular signature. So the signature function also depends upon the sender's private key and a set of parameters known to a group of communicating principals. So we can consider the set of constitute a global public key. Okay. So this is the DSS approach and this is the RSA approach. So here the message, here we are providing the encryption. After that this message is merely decrypted here, and again this is going to compare here. After that it is delivered here. After performing this, here the signature, digital signature is performed, and next at this message hash function is generated and it is verified here, and compared at this time. So this is a DSS approach. Okay. From this we have finished this unit. We will continue with the next class in the next unit.